I want to show you the debugger very quickly. Can we just put a breakpoint in line number 22, and we can delete the breakpoint from the earlier video, right? You can just double click on that, right? Used to be 13, but we can get rid of it. So now we only got one breakpoint in line number 22. And let's now press debug over here. Okay, and actually before this current breakpoint, we are still being prompted. We will still be prompted for these two values, but let's do that. Okay, and if I miss the console, I can always get it back. You can see the console here, right? Oh, sorry, not the terminal. Beg your pardon. You can always just maximize it, and the console is always here. Okay, enter a model. Let's say iPad Air, and also let's say I forgot the number I typed. So 2100.23, just for example. Okay, I do that, and now we are now going to switch to the debug perspective because we are now hitting the breakpoints. So I would say switch, and we are now in the debug perspective. You can see now we are in this line here, right before we are executing this particular line. You can see at this point, we don't see under variables P3, because P3 is only going to exist after the execution of this line. But this line has not been executed yet. That's what the breakpoint really means. All right, and we want to show you another feature for debugger, which is step into. We talked about step over in the earlier video, but now we can say step into. Step into means if there's any method you want to step into and see how it is executed, you can also do that. Okay, so I'm going to say step into. In that case, I'm switching the context into this particular constructor, the overloaded version. And then after that, I can actually see at the moment, so this is the context object, right? The context object has just been created, and all the attribute values over here are simply just default value. You can see over here, and the parameter model here, for example, model is iPad Air, and original price is 2100.23. That's exactly the input I actually entered from the keyboard, right? And I can now say step over, and for this, the model is assigned to model. I want you to pay attention to the model attribute over here. Currently, it is still none. And as soon as I say step over, it's going to be reassigned to something else. I say that, it now has become iPad Air. Similarly, for original price, currently it's 0.0. Oh, by the way, on Eclipse, it also highlights in yellow the attributes that have been modified by the method, by the lines of code, which is very handy. And then if I say step over again, so this original price has been changed from 0.0 into this value, and that's also highlighted in yellow. Okay, it's a very important skill for you to actually know how to use debugger, because whenever you get stuck in your code, debugger is your best friend to see what might be wrong. Okay, stop that, and then switch back to the Java perspective. All right. So that's about the console application. So now I would like to visualize on my iPad or like on the paper how you can create objects. And the most effective way, I think, for you to understand the tracing on the paper is to see its correspondence to the debugger. I think that'll be the most effective way. So let me relaunch the debugger, but I will reset the breakpoint in a different position. Let's go back to product app over here. And let me remove the breakpoint at line 22. You can double click on that. Okay, it's gone. I want to put it at line number 18. It's right before we try to prompt the user for the model, right? Let's not worry about this block of code over here for the tracing on the paper purpose, right? We only worry about how to trace these two different product objects. So that's the goal. Let me now launch the debugger over here, so you can expect as soon as I launch the debugger and switch to the debug perspective, I'm going to execute all the way non-stop and pause at this point right before we execute this line over here, right? I'm just keep reviewing about what debugger, what the semantics for debugger really is, what its meaning. It's really important. Okay, so let me now click on debug over here, and I want to switch to debug perspective. And now I'm pausing over here, right? You can see variable like a model OP and also P3, they do not exist under variables, right? You might be wondering what expressions panel really is. I'll get there maybe later. Okay. So now for variables, we have only P and P2. Okay, you can also see the address of P is exactly this address over here, and the address of P2 is exactly the second output over here, right? Now I want you to somehow maybe take a note, but I'll refer back to this. I will need to make use of these two addresses in a moment. I'll make use of them. Okay. Let me now switch to my iPad over here. Okay, I try to include everything that's going to be needed, but in a simplified fashion. Okay. Let me just tell you what we have in the setup over here. So we have our product class over here, and this part here is our are the attributes. And it's also very important for me to know that the attributes really determine the structure of your object at runtime. Oh, too thick. Attributes. And they really determine the structure of runtime objects, specifically objects of type products. Okay, so these are the 6 attributes, and we are considering 2 constructors. We are considering constructor number 1, the default one, and also constructor number 2, this guy over here. Right? You can see for constructor number 2, we are making use of this keyword, which I will also show to you how exactly that can be traced. Okay, let's now take a look at the application side, how we actually manipulate the model class. Right? You can just remember this product is one model class that we have developed so far, and we got instance creation in the console app. In this case, the same idea can be applied to when we try to create objects in the JUnit test cases, which we'll start doing in the next video. So this is our product app over here, and we actually try to create P and P2, right? Let's now trace line by line. And only for this time, I'm going to show you from the low level about how the computer memory is going to, how we're going to allocate some memory in the computer and try to maybe allocate these 2 regions for storing the 2 objects of products, and then we're going to store their addresses into P and also P2. That's roughly how we're going to see. Okay, but let's see precisely, and then I'll show you from now on. After this, I'll show you for later videos how we can simplify the visualization. We don't necessarily have to draw the computer memory every time. That'll be too time consuming. It's not necessary. Okay, let's now trace the console apps line by line. I want to trace this line first. How do we interpret this line? The way to do that is break it down into 3 parts. Part number 1, we're going to look at this slide over here about a new expression. So whenever we see the new keyword, so that means we are creating a new objects of this particular type. So we're calling the default constructor over here, right? So this is the constructor that we are calling, right? You can think about well, since we the compiler can easily tell because there's no parameter, so we know this is the version that's being called. And what that would do is he's going to see that, okay, products is actually this class, and that one we said structure of the objects at runtime will be determined by how many attributes you have. In this case, we got 1, 2, 3, 4, 5, 6. So just for illustration, what I will do is I'm going to actually allocate in the memory over here. So 1, 2, 3, 4, 5, 6. Let's say this region over here with 6 cells are going to store that particular products, right? And what's going to be the value, right? So that we can simply go by sequence. Model is actually a string. Default value would just be null, right? You can see here simply do nothing. And as we saw before in the debugger, it's going to be default value. So this will be null for model. For finish, it will be null as well. For storage, it will be 0. For this boolean, it should be false. And for original price, discount value 0.0, 0.0. And most importantly, what would be the starting address for this particular memory region? We want to identify this particular memory region, so we should know the memory address, and we can look back to the debugger. So that's why I said the paper tracing and the debugger tracing, they are consistent. If I go back to my Eclipse over here, so the first address is really this, right? Let me just simplify that just by product at this particular address, right? Let me just copy that. And then let me go back to iPad. and I'm going to paste it over here. Okay, so this is the address over here. This is the address. Okay, and that's the one. You know what? It might be even better if I can just make the color the same. Okay, so that's the address. So that's the first part. The first part is just about this new expression here. We're creating the products objects in the memory with this particular address by calling the default constructor. And then whenever when we want to what's the second part? The second part will be this part here, about the declaration of the object variable P. So what we're doing is we are creating this particular box. You can think about every variable in Java is like a placeholder, like a box. So here we got a box called P. And what P can store at the runtime is only address of product objects, right? At the runtime, it only stores address. We can say the address of some products objects. And of course, if you change the type of the object variable, the type of address it can store will change accordingly. And so this will be the second part, right? You can think about this as 1. We are creating this memory region. This will be 2, where we declare this variable over here. And it's really important to see number 3. Number 3 is the middle part over here. This is number 3, which is the assignment operator equal sign. So that means we're going to copy this address over here into P. So that's what we will do. So I'm just going to, let me just copy this address over here and put it into P, right? I'll just put it like that. Okay, you can see that one is storing this address over here. All right, hopefully so far so good. And let's now trace the second line of object creation. And of course, if you see that, see this line over here, when we try to print out P over here, you can see why it will just print out this address. That's what we saw on Eclipse over here, right? That's exactly what happened. Hopefully that's crystal clear to you. Let's now get to slightly more complicated case where the way we create the objects is by calling the overloaded version of the constructor rather than the default one, which is not too bad. So let's follow the same logic here. Let's just review. So we want to trace this particular line for P2. Right? Again, we're going to split it into 3 parts. I can speed up a little bit. First part is going to be allocate the some region in the memory for storing the objects. Right? Let's allocate the memory first. And then I'll show you how to trace the keyword this also. So let's say 1, 2, 3, 4, 5, 6. We got 6 attributes, right? Let's say this region here in the memory. Okay. And then what would be its address? Okay, let's put the address first. You can see from Eclipse, the address is actually this guy here, right? It's a different address. Let me copy that and let me paste it back to my iPad. Okay, so this is the address. It's definitely a different one. Okay, let me make it a little bit smaller and change its color. Okay, about the same size. And color should be pink. Okay, I'll put it here. Right, you can see it's two distinct regions in the memory to store 2 different objects. And now how do we initialize every field, every attribute over here? So now it's up to the definition of the constructor we are calling, right? You can see in this case we are calling the not the default version but the overloaded version because we are passing 2 arguments. So that means we're calling this version over here, right? Let's get it straight. So this is the version of the constructor that we are calling over here. More specifically, we are using input value iPad Pro 12.9. So that means model over here, every occurrence of the first input model is going to be replaced by iPad Pro 12.9. iPad Pro 12.9, right? You can see this model here. Remember, I showed to you how the Eclipse can identify which model it is referring to. So this model here is referring to the input. Similarly, every occurrence of original price is going to be replaced by the second input. So it's going to be 1289.00. Okay. So now we already work out what the right hand side for the assignment should be, right? The right hand side, we know that. And what we should do is about this. What's really this? You can think about this is really the object that we are creating. This is the object that we are creating, and the Java compiler can tell that eventually you want to store the reference into P2, right? But that's actually for the method call, but I'm just trying to mention that ahead of time. But in this particular case, this is really referring to just the context object that we're creating. And I actually mentioned this when I went over the slide together with you. Okay, so in this case, let me just highlight them, and then I'll put here to say the objects being created. Okay, so how do we interpret this particular line? When we say this, the model is assigned to model, okay, that means we're going to go to the objects and then go to its model part and then assign its value to be iPad Pro 12.9. That's what we'll do, because the right hand side is already that string value that we have worked out. And model should be the first attributes. So that means we're going to put it here. So that will be iPad Pro 12.9, right? And what about the second one? So this again will be this particular context object that we are talking about, and then we want to go to original price. It's kind of the second last attribute, right? The second last over here, and it's going to be assigned to original price, which is the second input. So it's going to be assigned to 1289.00. So please make sure you really understand how these two lines are being executed. That's really important. And the rest will just remain as default value. So this will be null as before, and also 0, and then false, and also 0.0, just default values as we spoke about. Okay, and so that's the first part, right? That's the first part. So this will be number 1. And number 2 is also to declare another variable of type products. And we're gonna have another placeholder here, P2. And P2 also similarly going to store the address of some products objects only. Okay, and then and the third part, last part, will be to actually store that particular address. So let me copy this address over here and then paste it here. Okay, so that's how we store the address into P2. Okay, you can try on your console application the following two expressions. You can try to say system the other print line. If you say P equals P2, and also P not equal to P2. If you got object variables of the same type, because P is of type products, P2 is of type products, so you can compare them using the equal. So this is really asking, are they referring to the same objects? Okay, let me just put some notes here. Are they pointing to or referring to? Are they referring to the same objects in the memory? In this case, no, because their addresses are simply different. So that means they represent distinct regions in the memory. So this part over here should give you false, right? And what about this part here? Since they are different, so P not the same address as P2, so that should be true. Right? Just make sure you understand these two simple Boolean expressions, right? I just want to mention that for completeness. Okay, so that's about complete tracing for object creation. And I want to mention that later on, whenever we want to trace object creation, I may not actually draw the computer memory diagram anymore. That'll be too time consuming. So what I will do is I'll simply do the following. So I might say P is simply store the address of some products objects, and the product object may be divided into several regions, and these are the attributes. Okay, that's how I'm going to do it. And similarly, I'm going to say also P2 is simply pointing to or store the address of just another object over here. You can see there are different boxes. That means there are different memory locations, and that's of the same type, products. And also you got several attributes over here as well. Okay, so This will be the way I'm going to trace the OO program for the subsequent videos. But you should really understand, these are really simplified version that's derived from the computer memory allocation that I'm trying to explain to you. All right, so in the next video, we'll try to add more methods into the product class.